Right now, somewhere in a Chinese shipyard, a vessel is taking shape that has the Pentagon more worried than any weapon system in decades. No smokestack, no fuel tanks, just raw nuclear power. And if the satellite images are correct, it's bigger than anything America has ever floated. When historians look back at the shift in global power during the 2020s, they might point to a single photograph. Taken from orbit in early 2024, the image shows a massive hull under construction at a Chinese naval facility. At first glance, it looks like any other carrier under development. But look closer and you'll notice something extraordinary. There's no exhaust system, no chimney rising from the deck. Because this ship doesn't burn fuel, it splits atoms. For years, whispers circulated in defense circles about China's ambitions to leap directly into nuclear-powered carrier technology. Most experts dismissed it as fantasy. After all, the United States took nearly 4 decades to make that same jump, moving from its first conventional carrier in 1922 to the nuclear-powered USS Enterprise in 1960. China's carrier program, by comparison, is barely out of its teenage years. The Liaoning, their first carrier, only entered service in 2012. How could a nation with less than 2 decades of carrier experience possibly master one of the most complex engineering challenges in naval history? And yet the evidence keeps piling up. Satellite surveillance, leaked shipyard models, American intelligence reports about reactor testing facilities. All of it points to the same stunning conclusion. China isn't just building a nuclear carrier. They're building one that might surpass America's finest. This isn't speculation anymore. This is happening. In the spring of last year, commercial satellite operators began capturing detailed overhead imagery of a construction site that military analysts immediately recognized. The dimensions were staggering. This wasn't a destroyer or a cruiser. This was honestly a floating city in the making. Experts started running calculations based on the visible structure. Length approximately 335 meters, width roughly 83 meters. Those numbers didn't just make it large, they made it larger than the USS Gerald R. Ford, the crown jewel of the American fleet and the most expensive warship ever constructed. Then came the displacement estimates. When analysts factored in the hull depth and internal compartments visible in the photos, they arrived at a figure that seemed almost unbelievable: 115,000 tons. The Ford displaces 112,000 tons fully loaded. If the Chinese estimates held true, this new vessel would be the heaviest aircraft carrier ever built. But size alone doesn't make a nuclear carrier. Plenty of nations can build big ships. What matters is what's under the deck. And that's when American media outlets started connecting dots that had been hiding in plain sight. Reporters discovered that China had been operating a land-based prototype facility designed to test maritime nuclear reactors. The reactor in question measured 10 meters in diameter and stood 15 meters tall. Every specification matched what you'd need to power a supercarrier. The thermal output, the cooling requirements, the shielding protocols, all of it aligned with a vessel designed for unlimited range and decades of operation without refueling. And then, just when the world thought the revelations were over, a Chinese shipbuilding corporation did something unprecedented. They released a promotional model of Carrier 004. Not an artist's impression, not a CGI rendering. An actual physical scale model, detailed and precise. People noticed immediately. The island superstructure was there, the flight deck layout was visible, the catapult tracks could be seen. But something was missing, something that's been on every Chinese carrier before and every conventional carrier in the world. There was no smokestack. Conventional carriers need exhaust systems to vent the gases from their boilers and turbines. It's non-negotiable. You can't hide it, and you can't fake it. The absence of a chimney meant only one thing. This ship doesn't burn fossil fuels. It runs on controlled nuclear fission, just like American and French carriers have for decades. The implications hit the defense community like a shockwave. So what exactly makes a nuclear carrier so formidable that only 2 nations have managed to build them? Let's break it down. A nuclear-powered aircraft carrier is essentially a mobile air base that can operate indefinitely without needing to refuel. While a conventional carrier might travel 22,000 kilometers on a full tank of bunker fuel, a nuclear carrier can cover 2 million kilometers before requiring new reactor cores. That's the equivalent of circling the Earth 50 times. The strategic advantage is almost incomprehensible. Think about what that means in practice. A diesel or gas turbine carrier needs a constant logistics tail, refueling ships, port calls, supply chains stretching back to home territory. Every time it needs fuel, it becomes vulnerable, predictable, and dependent. A nuclear carrier breaks that chain. It can remain on station for months, even years, without ever needing to return home for energy. The only limits are food, ammunition, and crew endurance. But the power supply advantage extends beyond propulsion. That reactor doesn't just drive the ship, it feeds everything on board. Radar systems that can track hundreds of targets simultaneously, electromagnetic catapults that can launch aircraft faster and more efficiently than steam systems, desalination plants producing thousands of gallons of fresh water daily, machine shops, hospitals, communications arrays, all of it drawing from an energy source that won't run dry. For a nation like China, with global ambitions but limited overseas bases, this changes the entire strategic calculus. A nuclear carrier battle group can project power anywhere on the planet without needing permission to refuel at foreign ports. It can maintain a presence in disputed waters indefinitely. It becomes, in military terminology, a mobile sovereign territory, a piece of China that can appear anywhere, anytime, and stay as long as necessary. Let's talk about what we think we know about this ship's capabilities, based on satellite analysis, leaked documents, and assessments from naval experts worldwide. The flight deck, measuring over 330 meters in length, would provide enough space to operate upwards of 80 aircraft. That's more than the Fujian, more than any carrier currently in Chinese service, and roughly equivalent to what the Ford class can handle. But it's not just about numbers, it's about the system managing those aircraft. Carrier 004 appears to feature 4 electromagnetic catapults. These aren't the old steam catapults that have launched carrier aircraft for generations. Electromagnetic systems use linear motors to accelerate planes down the deck, offering smoother launches, less mechanical stress, and the ability to adjust power based on the weight of each aircraft. The Fujian was China's first carrier to use this technology. The 004 would double down on it. The elevator configuration is equally revealing. 2 elevators positioned on the starboard side, forward of the island superstructure, one on the port side, aft. This layout maximizes efficiency, allowing aircraft to cycle between the hangar deck and flight deck without interfering with landing or launching operations. It's a design choice that prioritizes sustained combat operations, not just peacetime show. Then there's the reactor itself. According to leaked specifications, the nuclear power plant aboard Carrier 004 would generate approximately 125 megawatts. To put that in perspective, the Nimitz-class carriers, America's backbone fleet, run on reactors producing about 100 megawatts. That extra 25 megawatts might not sound like much, but in engineering terms, it's enormous. It means more power available for directed energy weapons, advanced radar systems, and future technologies we can only guess at. And China isn't planning for this carrier to operate alone. The naval strategy being developed pairs these supercarriers with Type 055 destroyers, some of the most advanced surface combatants afloat. These destroyers carry hypersonic anti-ship missiles with ranges exceeding 1,500 kilometers. Imagine the math, a carrier battle group that can launch aircraft 800 kilometers from a target, supported by destroyers firing missiles from 1,500 kilometers away. You create an engagement envelope so vast that approaching it becomes nearly impossible. This is the kind of layered defense that changes how wars are fought. Or more accurately, how wars are avoided. because no rational adversary engages a force with that much reach. But here's where the story gets even more interesting. While the world focused on Carrier 004, another piece of intelligence slipped into the reports almost unnoticed. According to American sources, construction has already begun on Carrier 005, not in the planning phase, not in the design stage, actually under construction at Jiangnan Shipyard in Shanghai. 2 nuclear carriers, being built simultaneously. The implications are staggering. If both vessels proceed on schedule, China could commission its first nuclear carrier by 2027 and its second by 2029. Renderings of Carrier 005 suggest it will feature a full-length straight deck, abandoning any remnants of the ski jump design used on earlier Chinese carriers. Straight decks maximize operational tempo, allowing aircraft to launch and recover in rapid succession without spatial conflicts. American analysts have run the projections. If China maintains its current pace, they could operate 10 carrier-capable battle groups by 2030. 10. That's nearly the same number the United States currently fields, built over the course of a century. China would achieve it in less than 2 decades, and the aircraft themselves are evolving just as rapidly. The J-35, China's answer to the F-35 stealth fighter, is expected to serve as the primary carrier-based aircraft on these new platforms. But there are whispers of something beyond that. Leaked images suggest development of a 6th-generation fighter, provisionally called the J-36, which could enter service within the next decade. If these carriers end up launching 6th-gen aircraft while American carriers are still flying 4th and 5th-gen platforms, the technological balance shifts yet again. It's worth pausing here to understand why this matters so profoundly to the United States. For over 70 years, American naval supremacy has been absolute. Since the end of World War II, no nation has seriously challenged U.S. control of the world's oceans. 11 nuclear carriers, supported by the most advanced submarine fleet ever assembled, have allowed America to project power globally with impunity. Trade routes, territorial disputes, international crises, all have been shaped by the knowledge that American carrier groups could appear on the horizon and fundamentally alter the strategic landscape. That era may be ending. China isn't trying to match the U.S. Navy ship for ship. They're targeting specific capabilities that would allow them to deny American access to vital regions. The Western Pacific, the South China Sea, the approaches to Taiwan, these are the waters where Chinese strategists believe future conflicts will be decided, and they're building a navy specifically optimized for those scenarios. The anxiety in Washington isn't about losing a hypothetical war, it's about losing the ability to dictate terms. For decades, the mere presence of an American carrier group was enough to de-escalate tensions. Now, China can meet that presence with equivalent firepower. The calculus changes, the risks multiply, and the certainty that has underpinned American foreign policy since 1945 starts to crack. There's also the psychological dimension. When China launched the Liaoning, it was easy to dismiss. A refurbished Soviet hull from the 1980s, powered by aging turbines, carrying a modest air wing. Cute, but not threatening. When the Shandong launched, it was China's first domestically built carrier, but still conventional, still limited by fuel range. Impressive progress, but nothing that kept admirals awake at night. The Fujian changed the conversation. Electromagnetic catapults put China in the same technological tier as the Ford class. But it was still diesel-powered, still bound by the same logistics chains as every other conventional carrier. Carrier 004 is different. If it launches successfully, it proves that China can master the complete spectrum of carrier technology in a time frame that shouldn't be possible. It demonstrates engineering sophistication, industrial capacity, and strategic patience. It signals that the gap between American and Chinese naval power isn't widening, it's closing fast. And maybe most troubling for Washington, it suggests that China's shipbuilding industry can outpace America's. The Ford-class program has been plagued by delays, cost overruns, and technical problems. The newest carriers in the class are years behind schedule. Meanwhile, China is preparing to launch 2 nuclear carriers in parallel, on time, and apparently under budget. Whoever controls the pace of shipbuilding controls the future of naval warfare. And right now, China is setting the pace. None of this is happening in a vacuum. The development of these carriers comes as China expands its overseas ambitions at an unprecedented rate. We're talking about naval bases in Djibouti, port agreements in Cambodia, Pakistan, and Sri Lanka. The Belt and Road Initiative is creating a network of friendly harbors across Africa, the Middle East, and Southeast Asia. A nuclear carrier gives all of this, teeth. It transforms what might just be commercial relationships into potential military staging grounds. It means that Chinese naval power isn't confined to the Western Pacific anymore. In theory, a carrier battle group based out of Gwadar in Pakistan could patrol the Indian Ocean indefinitely. Another operating from Djibouti could dominate the Red Sea and the approaches to the Suez Canal. The strategic chessboard expands, honestly, exponentially. And it's not just about intimidation. Carriers provide humanitarian relief, disaster response, and non-combatant evacuations. They offer diplomatic leverage. When a nation hosts a port call from a nuclear carrier, it's a statement. It says, "We are aligned with this power." As China's carrier fleet grows, so does its ability to play that card in regions where American influence has traditionally gone unchallenged. This is the part that keeps defense planners awake. Not the prospect of a carrier duel in the Pacific, though that's terrifying enough, but the slow, steady erosion of American strategic dominance through sheer presence. If Chinese carriers can be everywhere all the time, then the assumption that America controls the global commons, it just collapses. Let's address the elephant in the room. Is any of this confirmed? Officially? No. The Chinese government has not acknowledged that Carrier 004 is nuclear-powered. They haven't released displacement figures, reactor specifications, or launch dates. Everything we think we know comes from satellite imagery, intelligence leaks, media reports, and shipyard models. It's entirely possible that some details are wrong. Maybe the displacement is lower. Maybe the reactor isn't as powerful. Maybe the timeline slips. But here's the thing, even if half of what we believe turns out to be exaggerated, it's still a monumental achievement. Even a conventionally powered 100,000-ton carrier with electromagnetic catapults would represent a generational leap for the Chinese Navy. The fact that credible analysts believe it's nuclear-powered only underscores how far China has come. And we have to consider the source of much of this information. American intelligence agencies have no incentive to inflate Chinese capabilities. If anything, there's institutional pressure to downplay threats to avoid looking alarmist or justifying increased defense spending. When the Pentagon expresses concern about Chinese carrier development, it's worth taking seriously. The model revealed by the Chinese shipbuilding company is particularly compelling. Corporations don't release detailed models of non-existent ships. That model represents real engineering work, real design choices, real intentions. And the absence of a smokestack isn't something you overlook or fake. It's a deliberate statement. So where does this leave us? If Carrier 004 launches in the next 2 years, it will mark the end of an era. For the first time since the 1960s, the United States will face a peer competitor in the realm of nuclear-powered carriers. Not a near peer, not an aspirational rival, an actual peer, building equivalent platforms with comparable capabilities. The strategic implications ripple outward from there. Taiwan, the perpetual flashpoint, becomes even more precarious. A Chinese carrier group operating east of the island, combined with land-based air power from the mainland, would create an almost impenetrable barrier to American intervention. The balance of power, carefully maintained for decades, tilts. The South China Sea, where China has built artificial islands and claimed vast swaths of ocean as territorial waters, becomes harder to challenge. Freedom of navigation operations, where American warships transit through disputed areas to assert international law, become riskier when there's a nuclear carrier battle group nearby, ready to respond. The Indian Ocean, long considered an American lake patrolled by the Fifth Fleet, opens up to sustained Chinese presence. India, already wary of Chinese encirclement, finds itself facing carrier groups on both its eastern and western flanks. None of this means war is inevitable. In fact, the existence of powerful, balanced forces on both sides might make war less likely. Mutually assured devastation worked during the Cold War. Perhaps mutually assured stalemate will work in the Pacific. But it does mean the rules are changing. The assumptions that have governed great power politics since the end of World War II no longer hold. We're entering a multipolar naval world where dominance is contested, not assumed. There's a broader story here too, one that transcends carriers and catapults and reactor cores. For much of the late 20th century, Western observers assumed that China would follow a predictable path. It would open its economy, grow wealthy, and eventually embrace liberal democratic norms. Its military would remain large but unsophisticated, focused on homeland defense rather than power projection. The idea that China could challenge the United States technologically seemed fanciful. Carrier 004 is a symbol of how profoundly wrong those assumptions were. China didn't just copy Western designs. They studied them, absorbed the principles, and then innovated. Electromagnetic catapults, integrated electric propulsion, advanced reactors with higher output than American equivalents. These aren't Soviet-style knockoffs. These are indigenous technologies developed through a combination of espionage, engineering talent, and relentless investment. And the speed is what shocks people. 20 years from their first carrier to a nuclear supercarrier. The United States took 4 decades. France took even longer. China compressed the timeline by learning from everyone else's mistakes, pouring resources into targeted development, and refusing to accept incremental progress. It's a case study in national focus. While American shipyards struggle with cost overruns and political battles over contracts, Chinese shipyards operate with singular purpose. While the U.S. Navy juggles global commitments across 7 fleets, China concentrates on mastering one theater. While American defense budgets get diluted across hundreds of programs, China prioritizes the platforms that matter most for their strategic goals. None of this is to say China's approach is better or more moral. Authoritarian systems have advantages when it comes to long-term planning and resource allocation, but they come with enormous costs in freedom, transparency, and human rights. The point is simply that when a nation decides to achieve something and commits fully, the results can be stunning. What comes next is anybody's guess. If Carrier 004 launches successfully and proves operationally effective, expect the pace to accelerate. Carrier 005 is already under construction. Carrier 006 might not be far behind. By 2035, China could operate a carrier fleet rivaling America's in size and surpassing it in average age and technological sophistication. The U.S. Navy won't sit idle. Plans are already in motion for next-generation carriers, advanced submarine programs, and unmanned surface vessels designed to operate alongside traditional battle groups. The competition will drive innovation on both sides, which could lead to breakthroughs in energy systems, propulsion, and weaponry that extend far beyond military applications. But there's also the risk of miscalculation. When 2 powerful navies operate in close proximity, accidents happen. A collision between ships, a misinterpreted radar track, a warning shot that escalates. The South China Sea has already seen its share of near misses. Adding nuclear carriers to that mix raises the stakes immeasurably. Diplomacy becomes more critical, not less. Hotlines between commanders, protocols for unexpected encounters, agreements on safety zones and exclusion areas. The unsexy, bureaucratic work of preventing wars might matter more than the flashy weapons systems designed to fight them.